In this lecture, we're going to learn about bitwise logical operators. And these are mostly the same logical operators we have learned about before, but they are going to be working at the bit level. So we're going to be ANDing bits, ORing bits, XORing bits, and NOT-ing bits. In this table, we're going to see what these operations really do. We have two operands, A and B, and we're going to be looking at all these operators. We have A and B here. We have A or B here. We have not A. We use this symbol here to note that we're going to negate. And we use this operator here to note that we are going to be XORing. And the meaning of these operations is exactly what you see here. If you AND A and B are 0, you're going to get a 0. A is 0, B is 1, you're going to get a 0. A is 1, B is 0, you're going to get a 0. And if both A and B are 1s, you're going to get a 1. In other words, if you take two bits and do an AND operation, if one of them is 0, you're going to get a 0, and you're going to get a 1 only if both bits are 1s. OR is really what we have seen before. You're going to get a 1 if either of the operands is 1, and if both operands are 0s, you're going to get a 0. And this is what we have in this column here for the OR operation. The negation operator is going to negate. There is nothing more to explain about this. If we have a 0, we get a 1. If we have a 1, we get a 0. That's what we see here. But the XOR operation is only going to give you a 1 if either of the operands is a 1. But if both operands are 0 or 1, you're going to get a 0. And you might be asking, why should I care about these things? These things may come out very handy depending on some applications you might be doing. For example, if you interface to a lot of hardware in your C++ code, you might need these things, and you're going to be needing to do these kinds of operations on your bits inside your integers. Okay, you might be saying, this is really cool, but how do I do this in C++? Well, I'm glad you asked. Here is an example of how you can use the bitwise AND operator. We have two variables, value 1 and value 2. They are unsigned char, so they're going to take up 8 bits in memory, and we can only store in positive values. So we can print them out. We're going to print them out like this, value 1 and value 2. And you see that we are taking advantage of std bit set. Notice here that we are telling it that we have 8 bits in our value. This is important. You have to put it in here. And down here, you see that we can AND value 1 and value 2 using this operator here. This is bitwise AND. And what it's going to do, it's going to AND each bit from value 1 and value 2 at the same positions. So what we're going to do really is going to take the 1 here at position 0 and AND that with the AND at position 0 in value 2. We're going to take 1 and 0. We're going to take 0 and 1. We're going to take 0 and 0. And we're going to AND these things up. So if we really want to store the result here, we're going to get a 1 because A and 1 is 1. We're going to get a 0 here because 1 and 0 yields a 0. We're going to get a 0 here. We're going to get a 0 here. And we're going to get 4 zeros for these 4 bits that we have for value 1 and value 2. This is what we're going to be getting from this operation. And if we try to print this out here, we're going to see this on the terminal or the console. Here is an example of how you can do bitwise OR. It is really the same thing. You're going to be doing the OR operation on each bit of these two variables, and we're going to be getting the result here. You see that we're going to store the result back, and you're going to see that we are going to print this result using std bit set. We can also do NOT, and here you see that we have NOT value 1. This is going to flip off every bit in this variable here. We're going to have NOT value 2 here. We're going to print this out. We can pass a literal directly. Here we are using a binary literal. We can also use a hex literal if we want, and it is going to give us whatever it is we expect. In this case, we're going to be flipping off each bit in whatever variable that we are negating here. We have the XOR operation, and again, we're going to be carrying out this operation on each 2 bits in our variables. And we're going to be doing the operations on the bit that are at the same position here. Okay, so this is really all about these operators. I hope you have an idea about how we can work with them, but we still need to go to Visual Studio Code and try this out ourselves. Here we are in our working folder. We're going to grab the files from our template project as we always do. We're going to go to our current project, Logical Bitwise Operators. We're going to go in and we're going to open the project up in Visual Studio Code. Let's do that. We're going to open our main file. We're going to get rid of what we don't need here. We are going to put in our test code. The first thing you notice is that we need this set width manipulator, and you know that it lives in IO manip, so we're going to include that IO manip. And we also need std bitset here to be able to print our values in binary format. So we're going to include bitset here. Once we do this, we should be ready to run this piece of code. The first thing you see here, we have value 1, value 2, we have a few values inside, and this is the binary representation of these things. And we're going to print them out, value 1 and value 2, we're going to see them on the console, but we're going to bitwise AND them. And what this is going to do is take 1 and 1 here, it's going to AND them, we're going to store the result somewhere. It's going to AND them bit by bit. This is really what we mean by bitwise. So if we print this out, we expect to see 4 zeros in front, we're going to see 3 zeros in front, and we're going to have a 1 in this bit position here, which is the first bit. Okay, the convention where you are looking at your binary numbers, this is bit 0, this is bit 1, bit 2, bit 3, bit 4, bit 5, bit 6, bit 7, and this is the convention I am going to be using when I talk about my bits. So we are going to do the AND operation for the bits at position 0. We're going to get a 1, and all the other bits are going to give us a 0. This is what we expect to see when we print this out. Let's bring up our terminal so that we can see things printed out nicely here. And we're going to run the task to build with GCC. The build is going to be good. If we run Rooster, we're going to see value 1 is this value here. It is what we have here. Value 2 is this value. And we're going to AND them, and we're going to get exactly what we expect. All the others are going to give 0, except for the bits at position 0, which are all 1s. And if any of that doesn't make sense, please come back to this table and try to see that. If we have all 1s, we're going to get a 1. But if we don't have all 1s, we're going to get a 0 for the AND operation here. Okay, we have seen how we can do the AND operation. Let's try and do the OR operation. And we're going to do it like this. What we're going to really do is use value 1 or value 2. And we're going to print this out using std bitset. This is going to allow us to see this in binary. And we are using this column width here so that we see things aligned nicely. Let's build and see what this gives us. We're going to build with GCC, and we're going to run Rooster now. And we have our values. If we OR them, for the bit at position 0, we're going to get a 1 because OR gives you a 1 if either of the operands is 1. So we're going to get a 1 for bit position 0. That's here. We're going to get a 1 for bit position 1 because we have a 1 in here. That's the 1. And we're going to get a 1 for bit position 2 because we have a 1 here. And for the rest, we're going to get a 0. This is what we expect. This is how bitwise OR works. We can also take a look at bitwise NOT. Let's put that down here. And let's hide this tab here so that we can see the entire thing as best as we can, because some things you're not going to see these comments here. So we are trying to do a NOT operation, and we're going to negate value 1, we're going to negate value 2, and we're going to negate a literal here, and we're going to negate the same literal, but we're going to be passing that in hex here. The first one here was passed in binary format. And if we run this, we expect every single bit of this value that we pass here to be flipped off. If it's a 1, it's going to be a 0. If it's a 0, it's going to be a 1. That's what we mean here. We can build with GCC, and we're going to run this. And if we bring this up a little bit, we're going to see our value 1 and value 2 Let's clear so that we see the entire thing. I think it's really confusing there. Let's bring this up enough, and we run rooster. So we're going to see value 1, it's here, value 2, it's here, and we are interested in looking at the output for the NOT operator. So NOT value 1 is going to give us this, and you see that all the bits are flipped off. Where we had 0 in this value, we have a 1 now, and where we had 1s, we have zeros. And we can also flip off value 2. You're going to see that we're going to get exactly what we expect. Bits that are zeros are going to become 1s. Bits that are 1s are going to become zeros. We can also flip off a literal. We're going to do that, and we're going to get this result. We flip off the same literal. We're going to get the result that we expect here. This is how bitwise NOT works. And again, if you are confused by any of this, please come back to this table, and you're going to see how the negation operator really works. It's all here. Okay, we are making some progress. We're going to go down and look at the XOR operator. This is how you type it. And we're going to call the operator like we do here. And what it's going to do, it's going to take each bit in value 1 and XOR it with the corresponding bit in value 2. And what does the XOR operator do exactly? What the XOR operator does, it's going to give you a 1 if either of the operands is a 1. And if all operands are either 0 or 1, it's going to give you a 0. So for example here, it's all zeros, so we're going to get a 0. It's all 1s, we're going to get a 0. But 0 and 1, we're going to get a 1. And again, this may come in handy in some of the applications you're going to be doing with C++. Here is how you can do this in code. So we expect to XOR value 1 and value 2. If we build and run this, let's build with GCC. We're going to clear, and we're going to bring this up a little bit so that we see the entire thing. And we're going to run rooster. We have value 1 and value 2, and XOR is exactly what we expect. We have all 1s, we're going to get a 0. We have 1 and 0, we're going to get a 1. We have 0, 1, we're going to get a 1. And all the remaining bits are going to be zeros because it's all zeros. And this is really what we expect. This is how you can work with these bitwise logical operators. And they may come in handy in many C++ applications. In this lecture, I just wanted you to be aware of them. This is really all we set out to do in this lecture. I hope you found it interesting. We are going to stop here in this lecture. In the next one, we're going to learn about compound, logical, and shift operators.